Greetings and welcome to another installment of Quantslog. This is 39 in our basic application series, Lucky 39. This time around, we're going to close out our exciting summarizing data series, and we're going to do it in grand fashion. We're going to take a look at summary tables, and we're also going to take a peek at word clouds, sometimes called tag clouds. Two somewhat dissimilar topics, but I think we can pull it off. But before we get into all that, let's take a look at our previous Quantslog challenge. This is from part 10 of this series, the previous installment. So the question is, when graphically conveying the conditional bivariate distribution of two categorical attributes, how can we marry, so to say, the ease of interpretation we find with a percentage stacked bar chart with the cosmetic appeal of side-by-side pie charts? Well, I have something particular in mind. So let's start with the pie chart here. Now let's add a hole, and we end up with the so-called donut plot. Now, how it is that by cutting a hole into a pie, we end up with a donut is beyond me, but that's just what this is called. Notice now we can place another donut plot showing the conditional distribution of recentness for our other hemisphere, the northern hemisphere category, concentrically inside this donut plot. And here I think it's pretty easy to compare the colored regions across the two donuts. And I think it looks pretty nice. Looks nice. Donut plots I think have become pretty popular in infographics, but you don't really commonly see them too much in scholarly articles, really. Moving on. Summary tables. Now, summary tables are one of the most popular ways of summarizing data, especially traditionally and with respect to scholarly publications. Now, one thing to be aware of up front is that summary tables can vary considerably in look depending on the specific analysis that was performed and, of course, the software that rendered it, and also any embellishments or content the researchers added or maybe removed. But there's certainly some common themes. One is that they're typically used to show the relationship between a numerical attribute and one or two categorical attributes. So let's take a look at an example here using our Major League Baseball pitch-by-pitch data. So for each pitch, we have pitch velocity. This is the velocity of the pitch as it left the pitcher's hand. And we also have our simplified pitch type categorical attribute. It has two levels, off speed and heater. Now, somewhere in the table, usually near the top, we'll find a legend or a key that tells us the summary statistics that are included in the table cells and in what order they appear. So here in this example, the first number is the number of observations. This is the sample size of the particular subset. By the way, this does not depend on velocity at all. The second is the conditional minimum. Third is the conditional mean here. Fourth is the conditional median, otherwise known as Q2. The fifth is the conditional maximum. So, for example, the number of off-speed pitches in our data set is a little more than 2.2 million. The minimum velocity of off-speed pitches is 45 miles per hour. The average velocity of off-speed pitches is close to 82.1 miles per hour, and so on. So let's spice things up a little and look at velocity split by two categorical attributes, pitch type and the handedness of the pitcher that threw the pitch. Now, there's a lot of stuff going on here, but it's the same basic idea. So let's look at a couple statistics here. The value here, 82.52, is the average velocity in miles per hour of off-speed pitches thrown by right-handed pitchers. This value right here is a little bit over 1 million, is the number of heaters thrown by left-handed pitchers in our data. And for another example, the value here, 88.7, is the median velocity of pitches in miles per hour thrown by left-handed pitchers. So let's consider some mathematical notation while we're at it here now. Here's how we might symbolically represent the first and third values we just looked at. So first thing is, let's call pitch velocity x. So let's call our arithmetic average function just AVG. Our input is our collection of velocity values conditioned on the pitcher being right-handed, and also that the pitch was off speed. Same basic idea with our second example. We'll call our median function simply median, and our argument is velocity given that the pitch was thrown by a left-handed pitcher. Now, a couple comments before moving on here. Notice we're using multiple characters to represent some mathematical objects like the function and some of the variables. Mathematicians often avoid this, especially in pure mathematics. They prefer using single characters to represent their objects notationally. However, in computational math and applied math, this sort of explicit naming of objects is perfectly acceptable, very common. Moving on, word clouds, or they're sometimes called tag clouds here. So what's a word cloud? Well, a word cloud is a graphical representation of the popularity of words within a document. So let's take a few steps back here. So within the very broad science of language sits the study of natural language processing, or NLP for short. Within NLP is text analysis. Text analysis is about uncovering insights from text documents. And one simple and effective way to help in our quest to uncover insights from a text document is to examine the popularity of words within that document. Now, we have a couple examples prepared, but first thing that really needs to be said here is that although word clouds may visually appear different than other graphs, all the same basic data concepts apply. So for example, we have a rectangle of data, right? A data frame, stacked data. Here in this example, we're looking at 5 rows. Each row, of course, refers to a unit of observation. In this example, our unit of observation is a song, more specifically, a song by Taylor Swift, and more specifically still, one of the 5 most popular songs by Taylor Swift. Now, at this point, I should say that our focus here on Quantslab is statistics and data science. This is not a music channel, and I know some people are quite passionate about their music. So you may disagree on the choice here of top 5 Taylor Swift songs, ones we're going to be using in our following example here. This list is something I obtained online, and we're using it to illustrate word clouds. Okay, notice here we have an attribute, lyrics, the lyrics of the songs. Now, what type of attribute or variable is lyrics? Well, it's certainly not numerical. It is, in fact, simply a categorical attribute. Now, it's maybe a little atypical compared with what data scientists routinely work with, in that the labels that make up these categories are really long. They're very long strings of characters. So for this example, we're going to combine, or have our software combine, all 5 blocks of text, each song, the lyrics, into a single text document. Now, spiritually, this is similar to how we might just copy and paste a block of text from one document into another. Now, we can pre-process this text in a number of different ways. So commonly, we remove punctuation. We may also want to convert all characters to uppercase, and it's common to remove so-called stop words. Now, these are words, often prepositions and articles, that are very common in spoken and written language, but are not by themselves usually regarded as important. Now, our final step is to enumerate all the unique words here. Sometimes the words are called tokens. In our text document here, and so we're going to count up how many times each occurs. This allows us to create a new data frame known as a word frequency matrix. It is this word frequency matrix here that our software uses to build our word cloud. Now, the software prints each word or token close together, but hopefully without overplotting and possibly in varying orientation. So here you can see we got horizontal and we got some vertical words here. And we plot them such that the frequency is proportional to the font size. So now, for example, I appears to be the most frequent. You, me, a little less frequent. Baby, less frequent still. And ooh, 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 ooh. Here, it makes a showing. So we've come this far. Let's do the same for opeth. Again, no complaints about the song selection. I just got these top 5 online. We execute the same process we previously employed, and presto, here we go. Pretty interesting. In a preposition that was not removed as a stop word is the most frequent word. My possessive determiner is also relatively quite frequent. And of course, here, death and perdition make a showing. Now, unlike with many other types of graphs, we would not make a word cloud by hand. There's plenty of software out there for this, and there's even some really nice online web applications available for creating word clouds. I'll put a link to 1 or 2 in the description. Now, finally, time for our Quantslab challenge. Question. First, we remember the key theme we introduced way back in part 1 of summarizing data here, and that is that data summaries are really about facilitating comparison. So, question here. Looking at these two word clouds, what differences really stand out in terms of the lyrical vocabulary between the top 5 songs of Opeth and the top 5 of Taylor Swift here? There's a lot of possible answers to this, of course. We're going to pick this up in our Quantslob Season 5 kicker. That's it. That's going to do it this time around. Thank you very much for tuning in. I really do appreciate it. Don't forget to stay tuned for more Quantslob.